So I want to welcome everybody to Electronic Fundamentals. My name is Professor Ron Singleton. You can call me Professor Ron, or you can call me Ron or Professor Singleton, whatever you want, doesn't really matter. Um, I'll be your instructor for the next 15 weeks, and think you'll learn a lot. Hopefully you'll enjoy the class. I did send out a video link, kind of an introduction, just kind of a general introduction for all my classes. I don't know if you had a chance to watch that, but you do want to go watch that, kind of go through the syllabus in detail. And I have a few other things that I mentioned in that video that you'll need for the class. I will briefly go through the syllabus today, but I'm not going to spend a whole lot of time going through the syllabus. You should definitely go back and watch that video. Before we get started, there is a number on the board. The way I take attendance is I have you text this number, and in the text, you'll write or type EET student or EET 101, and you want to put your first name and your last name in that text. So go ahead right now, text this number, 513-494-6162. You might want to go ahead and save that in your device because you'll do this pretty much every time we meet. It's important that I turn in attendance really for the whole semester, but the first 2 weeks at any class here at Cincinnati State is important because if you don't show attendance, it affects your financial aid. So just to make sure there's no problems with financial aid, even if I don't ask you to do this, always start the class by texting this number. So go ahead and save that number in your device, 513-494-6162. Write EET 101 in the text, and then follow that with your first name and your last name. Send that to me, and I'll take the attendance that way. So go ahead and take a minute to do that. And then while you're doing that, I want to set the syllabus up so we can talk about that real quick. And then we're going to jump right into the course material. Since we missed Monday, we're kind of behind already, but not a big deal. We'll get caught up. And while you're doing that, there's a sheet. If you go to Blackboard, course documents, week 1, there's a sheet in there called a topic sheet. I'm going to refer to that topic sheet today for today's lecture. You want to go ahead and if you can print that out, that would be nice. If not, at least have it open on your device. And if you can't do either one of those, there's some practice problems I want to do if we get to that today. I'll put them on the board in case you don't have it, but it always helps to have this in front of you when we're going over stuff. So go ahead and send me the text, and then print out the topic sheet, or at least open it up on your device. And then I'm going to go ahead and share the syllabus with you, and then we'll start the class. So you should now be able to see the syllabus. And if you go up to the upper left-hand corner, right under that hamburger menu, you'll see a little magnifying glass. You can click that, and that allows you to make that file that you're viewing a lot bigger. So expand that so you can see it, and you're looking at the syllabus. And the course number first, everybody should be in EET 101, section 001. The title of this course is Electronic Fundamentals, and as I said before, I'm your instructor, Ron Singleton. Just a little bit about me. I've been teaching since 1996, and I know some of you probably weren't even born in 1996. I've been teaching since 1996. At some place or another, I taught high school math for a few years. I'm an adjunct at University of Cincinnati, and I'm a full-time instructor here at Cincinnati State. I've been at UC since 1999, and I've been at Cincinnati State since 2013. So that's a little bit about me. Normally, on the first day of class, I have you guys go around and kind of introduce yourself, kind of like a meet and greet type thing. But considering the circumstances and the way we have to talk to each other, we'll forego that now. However, you will come in certain days for lab, and then we'll get a chance to meet each other. So maybe we'll do a meet and greet during your first lab session. That will not be, obviously it wasn't this week, and it probably won't be next week either. I'll let you know when we're going to meet face to face. A couple things with that. I want to keep a I take care of my mom who's in close to 80 years old, so I got to make sure I stay safe. I know you want to stay safe. We're just going to kind of watch the numbers. Probably we'll plan the week after next. We'll probably have our first lab meeting. Okay, so I'll make adjustments in the schedule to reflect that. Let's go to the syllabus. The thing I want to emphasize here in the video, that was an old video I think for last summer. So I just kind of, this is the updated syllabus. And the main thing here to realize is these office hours. I have these office hours listed. Now these are the actual days and times that I'm on campus. I'm on campus and available for you to meet with me either by phone, or I can send you a link. We can work through the camera. Or if you want to, I know in the video I said I would not do face-to-face, but I'm a little more comfortable doing that now as long as we stay, socially distanced apart and we have on the mask. I think I'm okay with that. Now, you will be coming up here certain days for lab, so that's also time that we can meet because I think you have like 3 hours for lab, and to be honest with you, no lab that we will do will take 3 hours. Now, if we do more than one lab, which we'll probably end up doing, more than one lab in a day, we can take a couple hours, but I think there'll pretty much always be time in lab where we can sit down and we can go over material if we need to do that. So that's one thing that's different from the video. My contact information, email, office phone, texting is the best way to send a message to me. So that number there is not a cell phone. I use a Google Voice system. It's just a number. Pretty much anything you can do with a cell phone, you can do with that number. You can text me. You can leave voicemail. Excuse me. You can even send a video or picture to that link if you have to. So if you got to get in touch with me, if it's not too urgent, you can email me. If you want me to get the message pretty much right away, text me. And feel free to text me at any time or hour. If I'm asleep or doing something, my computer's off, I'll never see the text until I'm ready to get on the computer. So there's never a wrong time to text me. The description, you can read that yourself. The schedule there, the topics and chapters for the book. Well, by the way, there is a book, but the topics are listed there, and I pretty much stick to that. Sometimes I might have to make some minor adjustments. And with the virus situation, I might make major adjustments. But we'll pretty much try to stick to this as much as possible. Okay? And then what you're probably really interested in, well, here's the book down here. You can see the name of the book. I don't have the ISBN number on here, but if you need it, you can let me know. There is the grading criteria. So that you probably want to know, how do I get an A or a B in this course? Well, first of all, I grade on a 10-point scale. So 90 to 100 is an A, 80 to 89 is a B, so forth. And then the actual tests, exams, quizzes, homeworks, lab, there is the breakdown for each of those categories. You'll have, or we'll attempt to have, 4 exams. Each exam is 15% of your grade. Now with this class, there will be at least 1 take-home exam, possibly 2. The final exam will be in class, but it just depends. Sometimes it's just best to do take-home exams. I know students like that because you have more time and resources you can use. But if we do an exam on campus, of course, it'll be done during our lab period. So just realize there's 4 exams and they're 15% apiece. Quizzes are 15%. Now, I did make one change that is not reflected in that video if you watched it. In the video, it says that I would drop 2 of the lowest quizzes. I decided to drop 3 of the lowest quizzes because of the situation with the virus. Last semester, I had some students that had to quarantine. You got to quarantine for at least 2 weeks. And if you do that for 2 weeks, that's your 2 grades right there. So I figured to be a little bit more flexible, to give you more time. In case somebody has to quarantine, I'll give you 3 weeks, so I'll drop the 3 lowest grades. So you can, what I'm saying is you can completely miss or get a 0 on 3 quizzes, and it won't affect your grade in any way. So Don't ask for a makeup quiz. I don't give makeup quizzes. Because I don't give makeup quizzes, I'm going to drop the 3 lowest quizzes. And in addition to that, throughout the semester, I'll give you these outside assignments that you'll do that will count as quiz grades. And those assignments, it's pretty easy to get 100 on those as long as you do them. A lot of times students won't do those assignments and then it'll pull your grade down. As long as you take advantage of that and just try your best in the class, I'm sure you'll do fine. So other than that, the rest of this you can read yourself. Does anybody have any questions for me over the syllabus or in general before we start? Okay. Well, if you do, you can ask me after class or you can send me a text. And what I want to do now is actually get into the course material. Couple rules I want to talk about before we start. When we're lecturing or when I'm lecturing, you want to make sure your microphone is muted. If you need to ask a question, there's 2 ways you can do that with Collaborate. You can just start talking, which I prefer, or you can send a message through text, which I don't mind that, but I'm looking at you and the camera right now, and if you see me look off over to the side, that's where my computer screen is. And the problem is I can't see those messages when you send those. I actually have to step out of the camera frame to read it. So if you need to ask a question, feel free to interrupt me, unmute your mic, ask your question, and then mute your mic back and ask for a response. Sometimes students will unmute their mic, and what happens with this Collaborate system, who's ever talking, the video cuts away and goes to who's talking. So if you have a dog in the background barking and your mic is unmuted, it's going to cut away from me and go to you. The other thing is you don't have to do this, but I'll get a chance to see you guys and meet you when you come in for lab. But it is nice to see your face and to know who you are. So, you know, if your hair is not messed up and you're not in your night clothes, you might want to think about opening up your camera so you guys can see we can all see who each other, what everyone looks like. And again, you don't have to do that. You'll see each other during the lab, and that'll work also. You will need a 3-ring binder. You will need a 3-hole punch. The reason you need that is I give a lot of handouts, and what I recommend you do is you print those handouts out, you 3-hole punch them, put them in the binder, and then you'll have your textbook, a separate supplementary to the textbook, everything in order, and you can use that to study for quizzes and to stay organized. You'll also need a digital multimeter. Now I mentioned that I think in the syllabus. I think I mentioned in the syllabus, but for Lab 1, you'll have to go buy a digital multimeter, and you don't have to spend a lot of money on one of those. You can spend $20 on it, $25. Get them from Lowe's, Home Depot, online. Digital multimeter. You want to make sure it's a digital multimeter and not an analog multimeter. The digital one has digital numbers that instead of a needle that moves. You want the one with the display, the digital display. So you'll need one of those, and then the first lab is actually already posted. I got to give you the instructions, but basically it's this. There's a video that when you get your meter, you want to have that meter right there in front of you and watch this video and just kind of take notes and kind of follow what the guy does in the video and have your meter right there. The purpose is to become familiar with 3 quantities: voltage, current, and resistance, and how you use your meter to measure those quantities. That's that first lab, and what you'll do for a grade is just kind of give me a summary of what the video is about, and you'll send me a picture of your multimeter. So you want to go ahead and grab that as soon as you can. Again, you can have it shipped or go to a hardware, buy one. I wouldn't spend much more than $25, $30 on one. They can go up to literally hundreds of dollars, but for what we're going to do here, one that's around $30 will probably be fine. Okay, so if you have any questions about that or what to buy, you can ask me later. So, assuming that everybody's sent this text, if you didn't do that, go ahead and text me at this number. In the text, EET101, put first name, last name. That's the way I'll take attendance. Go ahead and save that number in your device, and I will use that method to take attendance. So even if I don't ask for it, go ahead and text me. That way I have a record of who attended classes. So we'll go ahead and start. Anybody have any general questions before we start? Okay. Well, I have a topic sheet, and I'm going to go through the topic sheet. I probably won't get through the whole thing today, but we'll get through as much as we can. So I want to start with the first Roman numeral number 1. And basically, the statement, it says mathematics, the language, and that's in quotation marks. Mathematics, the language of science and engineering. I want to start out by saying that in this class, you do calculations, and to get those calculations, I'll give you equations. Well, the language of science, the language of engineering, the way we communicate, we can communicate verbally. I can show you pictures, I can show you diagrams, but the main way we communicate in science and engineering, we use the language of mathematics. That's important to understand. It's a good starting point, because what I want you to do with that statement is understand that when I give you an equation, all too often I give equations, a student will get an equation and they'll see the equation is just the way to get to an answer. And it is that. It's a way to get the answer. But what you really want to ask is, what is this equation saying to me? What is it trying to communicate to me? And the way to understand that is by looking at relationships between quantities. So as we go through the course, I'll make that more and more clear. The answer is always important, of course it is, but often what's more important is how those quantities in the equation relate to each other, and what are those relationships trying to say to you? How is that equation speaking to you? And as we go through the course, I'll mention that. Another thing to deal with here in this class is quantities. What is a quantity? A physical quantity. Well, a physical quantity, every physical quantity, if you want to represent a physical quantity, takes two pieces of information. Every physical quantity is represented by a number and a unit. So I want to spend some time talking about the way we represent numbers in this class. There's two ways we represent numbers, main ways. We can use something called scientific. I'll just put the notation. There's two notations. There's scientific notation and engineering notation. So I'm going to start with that. And then here, the unit, there's these different systems. Different systems of units. I want to spend some time talking about that. But we'll start by understanding to represent any quantity, I got to have two pieces of information. I got to have a number, and I got to have a unit. So let's deal with numbers first. It turns out in science and engineering that, especially in science and engineering, that some of the quantities we represent are really, really, really big. Some are really, really, really small. One example of something really, really, really big might be the distance between celestial bodies. Say the difference between the distance between the Earth and the Sun. The distance between the Earth and the Sun is 93 million miles. That's a big distance. Or the distance between the Earth and the closest star, well, the distance between the Earth and the closest star is the Sun, 93 million miles. But the next closest star to the Earth is 4 light years away. Now think about that. The next closest star to the Earth that you can see is 4 light years away. What's a light year? Well, a light year is the distance that light will travel in 1 year. If you think about the speed of light, light travels at 186,000, not 186,000 miles an hour. Light travels at 186,000 miles each second. So even traveling that fast, 186,000 miles a second, it will take 1 year for the light to leave a star and reach your eye if that star is 1 light year away. And here we're talking about the next closest star is 4 light years away. You can't imagine a distance that vast. As a matter of fact, we have planets and galaxies and stars that are literally hundreds of light years away. You can't imagine a distance that big, but yet scientists have to do calculations with numbers that big, that huge. Or go the other way. Think about the size of an atom. Extremely small measurements, extremely small quantities. There's a lot of there's a decimal place and a lot of zeros before you get to an actual number that makes sense. We deal with the infinitely big, we deal with the infinitesimally small, so our numbers can be really, really big or really, really tiny. And so what scientific notation is a way for us to handle or manage those quantities that are really big or really small. So I want to spend some time talking about scientific notation. But what I really want to get to is this second type of notation called engineering notation, because that's the language we use in this class. At any point, feel free to interrupt me if you have a question. Like I said, just unmute your mic, then mute it back, and I'll answer your question. And then I want to work some examples. I don't want to just talk. I want you guys to actually work some problems and get used to what we're doing. This topic of scientific notation, most students have already done this before. You might have had in your math class or chemistry or most people have done this before, but there's always a few that this is your first time seeing this. So in this class, what I do is I assume everybody knows nothing, and we just kind of come up together. So if you've done this before, I apologize. Just consider it a review. We'll go through it, and we'll get to something that you don't know about. Okay, so what is scientific notation? Scientific notation is a convenient way to represent really large numbers or really small numbers. And the way you write a number in scientific notation, the form the number takes is this. There'll be a number, there'll be a decimal point, and then there may or may not be a number after the decimal point. There'll be the multiplication sign, and then there'll be this 10 to some power. So this is called the exponent or the power. I'll just call it the power. This leading number, the number on the left side of the zero, cannot be, the left side of the decimal point. It cannot be a zero. So it has to be the digits 1 through 9. Cannot be a zero to be in scientific notation. And then what happens is you start with a decimal number, and depending on the number, you're going to either move the decimal from the left or from the right, and you're going to count the number of times you move it to get it into this form. And that's what this represents. That power represents the number of times you move the decimal from the left or from the right. You keep count of that until you get it into the form where there's one place to the left, the decimal point where there's not a zero. And then you have it in scientific notation, but you got to do one more thing. You got to write whether this exponent is positive or negative. And the way you determine that is, if the original number you start with is bigger than 1, then that exponent is going to be positive. If the original number you start with is between 0 and 1, then that number is going to be negative. So I know I said a whole lot, but it's really, really simple. Let's do this twice. Let's do this with a number that's bigger than 1. We'll use that distance between the Earth and the Sun. We'll use 93 million. And then we'll start with a smaller number like 0.000123. And I want to put those in scientific notation. I want to put it in this form. So the first thing I'm going to do is I'm going to locate my decimal point. Now, let me just say one thing. In science, sometimes they won't put these commas in there. They'll just write this like this. They'll space these zeros, they'll make them groups of 3s. Now, I'll do that sometimes. Sometimes I'll put the commas in there. The reason for that is, in some culture, a comma and decimal point mean, like, we might write 1.32. Well, in some cultures, they'll write 1, and they'll use the comma as a decimal point. So they'll write 1.32. In some cultures, this has the same meaning in their culture as the decimal point has in ours. I know I had a couple African students that was the way they did it. So and often in science books, they'll just leave out the comma and they'll put spaces there. But if you want to put those in there, sometimes I'll do that, sometimes I won't. Let's put this in scientific notation. The first thing I'll do is I'll locate my decimal. I know it's over here on the right. And then what I'm going to do is move that decimal over to the left, and I'm going to keep counting the number of times I moved it until I get to one place to the left of the decimal that's not a zero. And then I'm going to write that number, how many times I moved it as my power. So I'm going to start here. I'm going to move this 1, 2, 3, 4, 5, 6, 7. I got to put the decimal right here. So I'm going to write this as 9.3. So it's in this form. One place to the left of the decimal, and it's not a zero, times 10 to the, how many times did I move it? Well, I moved that decimal 7 times. So to put this in scientific notation, 9.3 times 10 to the 7th, and I'm almost done. The last thing I got to do is I got to write that 7 as a positive number, or leave it as a positive number, or a negative number. Which one is it? And the way you determine that, if the original number I started with is bigger than 1, the exponent is positive. If that original number is between 0 and 1, the exponent is negative. And since 93 million is bigger than 1, I'm going to leave this as a positive number. I'm done. 9.3 times 10 to the 7th power, scientific notation. Okay, well, that wasn't too bad. What about this one? Let's put this one in scientific notation. I'm going to do the same thing. Now, for this, my decimal point's already there, so I'm going to move it over. 1, 2, 3. I can't stop there. I can't have a 0 on the left side of the decimal point, so I got to go one more. So if I write this one in scientific notation, it's going to be 1.23, and I moved it 1, 2, 3, 4. So it's times 10 to the 4th power. And there you go. I got that number in scientific notation. One place to the left of the decimal, and that first place to the left of the decimal is not a 0. And so that's scientific notation. Got to do one more thing. I got to check, is that exponent going to be positive or is it going to be negative? The exponent is positive if the original number I start with is bigger than 1. The exponent is negative if the original number I start with is between 0 and 1. And since 0.000123 is between 0 and 1, that means that this exponent is going to be negative. So it's pretty simple. Once you get the hang of it, do it a couple times. It's really simple. And I can go the other way. I can take a number. Given this, I can take the number out of scientific notation. That means I'm going to just do the same thing in reverse, right? I got to move it over 7 places. I got a 3 right there already. That's one of the 7. That means I got to add 6 zeros to it and move it over. And I do the opposite here. So what I want to do is I want to practice doing that. And again, I know that some of you have already done this before. I promise you, you'll get to some stuff you haven't done before. But for now, if you've done it before, just consider it a review. If you haven't done it before, please try to understand how it's done. And if something's not clear, you can ask me about it. What I want to do right now is practice doing this. So if you have the topic sheet handy, you'll notice at the very bottom of the page, there are these practice problems. And what I do is, this topic sheet is kind of an outline of the chapter, the main parts I want to go over. And I always give practice problems so you can kind of know what to expect on the quiz and kind of see how the calculations go. So what I want you to do right now is problem number 1 and 2 at the bottom of the page. Problem number 1, they want you to write those numbers in scientific notation. Problem number 2, they want you to take numbers in scientific notation and take them out and put them in decimal notation. Now, just in case you don't have this topic sheet handy, I'm going to put these problems on the board, but try to have the topic sheet handy so you can write on it in future classes. So go ahead and see what you can do with problem number 1 and 2. And while you're calculating, I will put those problems on the board in case you don't have your sheet, and then we'll go ahead and we'll work them. All right, so there you go, and then label A through F. So I'll go ahead and label those and see what you can do with those, and then we'll talk about them in just a second. Now, guys, please make sure you're working these. I taught this last semester, and this should be, I'm not going to say an easy course, but it shouldn't be that difficult. I think sometimes students are at home and they're distracted. You're on, the camera's on, but you're doing something else. You're not really paying attention. You think you're going to go, by the way, I'm recording all of this, so you'll be able to go back and watch the recording. But recording is not a replacement for actually attending class. You want to actually come and work the problem so that if you get stuck, you can ask me questions. So don't just sit there. Make sure you're working along with me or with us as a class. And then if you get stuck, ask questions and then we'll work it out. So see what you can do with this. I'll give you a few minutes. I'll come back in a few minutes and then we'll work it out. McCain holiday kind of threw us off, but I'm not complaining. I like being off and getting paid at the same time. All right, so let's do this. Anybody got an answer for the first one? What'd you get? Tell me what you got. Don't be afraid.
5.6 times 10 to the
what?
fourth power.
That's right. Okay, so what he said was decimal here, moved over 1, 2, 3, 4. He got 5.6 times 10 to the fourth, and that would be correct. Now, at any point, if you don't understand why we got the answer that we got, make sure you ask. Don't let me go on. If not, you're going to run into trouble. What about that next one? What'd you get for the next one? How many times do I move it? One 1.2 times 10 to the what?
6.
6. So you should have got that. Now this one, be careful on the next one because that's one that's the decimal here is over on the left. So I got to move it 1, 2. That brown isn't working at all. So what? Now I want to move it over. It's going to be 5 times 10 to the. I have to move it 1, 2 times, so it's a 2 there. But since this number is between 0 and 1, I got to write this as a -2. So make sure you don't forget that. The same with this one, right? The decimal's over here on the left, so I'm going to go 1, 2, 3. So it's 4.72 times 10 to the third. But again, since this is a decimal number, anytime you have a decimal number, I said decimal number, I mean the decimal is over here on the left, then you always end up with a negative exponent. So here, you got to be careful. I think I counted right. I think I counted 10 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think if I did it right, I get 5.6 times 10 to the 11 times was a -11. Now I don't know. I didn't have my glasses on when I counted that. So if there was actually 10 zeros after the decimal point, then that should be the answer. And that last one is kind of stupid. I mean, it's 1.3, 1.3, and it's already in scientific notation. I got a 1 there on the left. You can write it like this if you want to. And I don't have to move the decimal at all. Just 10 to the 0, but typically you don't do that. Okay, so everybody see how to take a number and put it in scientific notation. It should be pretty simple. But if it's not, let me know and we can review anything. Is that all right with everybody? Everybody all right? See what we're doing? Okay. Well, is this class over at 11:20 or 11:30? Anybody know? What time is the class over?
11:20.
11:20. Okay. Well, I think what I'm going to do is we'll do the other problem. We'll take the number and we'll take it out of scientific notation, and then I'll do one more thing. I'm going to write this table down called the table of metric prefixes, and I'll pick up with that on Monday. That's what I want you to study, and we'll start with that on Monday. So let's do the other part, problem number 2 real quick, and I'll give you that table of metric prefixes, and I wish we could get through it today, but it's just too much. I think if I hadn't started talking about the syllabus, I probably would have got through it today, but I want to make sure that you guys understood what was in the syllabus. So, but number 2 is real simple. If you can put numbers in the scientific notation, you can take them out. Just do the opposite. So for this one, we have, let me get my glasses. I can't see anything without them anymore. Okay, so we have 4 problems. We have this one. All right, so I don't know how you do it. As long as you get the right answer, I don't care how you do it. But what I usually do is I just add zeros to the number. Like for this, I know since this is a 7, I know it's a number bigger than 1, so I got to move the decimal to the right. I know that just by looking at it. And I know I got to move it 7 places, right? Well, 2 of the places already have numbers in it. So I only have to add to move 7. I have to add 5 zeros to that. 5 plus 2 is 7. So I'm going to write 2.66. That's 2 of the 7. I'm going to add 1, 2, 3, 4, 5 zeros to that. So if I do that, and my decimal now is over here, put my commas in there, and there's my number. So this is like really simple. So if you do that here, I got to add zeros out front. I got to move it over 8 places. So I don't want to add 8 zeros because I already got 3 for one of them. I add 7 zeros out front. 1, 2, 3, 4, 5, 6, 7, 3, 7, 5, and then I put my decimal right there. Now, anytime you're dealing with a number where it has a decimal point on the left, you always want to put a 0 on the other side of that decimal point. I mean, it's not wrong to do it this way, but it looks kind of silly. If you put that 0 over here, that kind of helps that decimal point stand out. So I wouldn't mark it wrong if you had that, but I would like it better if you put the 0 out front. And then this is done the same way. I got to move it over 2 places, but I got one of the places. The 5 is already taken that up, so I'll just add 1 0 to that. Put my decimal point and then the 0. And this I'll move it the other way. There's 2 places, so I got to add 2 zeros to it. So I'll do this, add my 2 zeros, and then move this over. And that gives me 16,700. So I think that's a non-issue for most students. If you can put numbers into scientific notation, you can take them out of scientific notation. Now I got about 2 or 3 minutes. I want to close by doing this. I want to give you this table. I want you to, I don't really like you to memorize anything. I think you should understand but not memorize. But this is one thing you got to memorize. This is called the table of metric prefixes. So I'm going to give you this table. I want you to study it over the weekend, and I'll pick up with this on Monday. Now this table is going to be on quiz 2. Quiz 1 will be really simple. You'll laugh at that. Everybody will get an A. But quiz 2 will reflect this information I'm talking about now. So write this down, and then we'll end today, and we'll pick up with this next Monday. The table of metric prefixes. There's 3 columns. The first one is the prefix. The prefixes are mega, kilo, milli, micro, nano, and pico. So the first column is the prefix. Then there's the power of 10. I'm just going to write power, but you might want to write power of 10. So the power of 10 for mega is 10 to the 6. That's a 1, and the exponent tells you the number of zeros to add to the 1. Add 6 zeros. Mega means 1 million. Kilo is 10 to the 3rd. That's a 1 with 3 zeros. Kilo means 1,000. So that's the way you think about that. So the powers are 10 to the 6th, 10 to the 3rd. Milli is 10 to the -3rd. Micro is 10 to the -6. Nano is 10 to the -9. And pico is 10 to the -12. And then the last column is just a symbol. Each power of 10 has an associated symbol. Mega is a capital M. Kilo is a lowercase k. Milli is a lowercase m. Micro, now a lot of times micro, people use a U, but the actual symbol is this. It's like a U with a tail in the front. That's the Greek letter mu. You can use a U if you want, but the actual way to do it is like that. So this is mu, nano is a lowercase n, and pico is a lowercase p. This is called the table of metric prefixes. Now, in your book, they may have more prefixes, but for this class, these are the only ones you got to know. Let me say one more thing before we sign off of here. It's important, very important, that you make an uppercase M look like an uppercase M and a lowercase m look like a lowercase m. And I'll explain why that's important, on Monday. But here's what I'm saying. Some students will make a uppercase M like this and a lowercase m like that. They'll just make the lowercase letters smaller. Well, this actually is just a big lowercase m. If you want to make an uppercase M, you got to show the points on it like that. I don't care how small you make it. Making it small doesn't make it lowercase. This is uppercase if it has the sharp points on it, and it's lowercase if it's rounded. I'm not being silly. This actually is very important that your uppercase letters look like uppercase letters, and your lowercase letters look like lowercase letters. So what I want you to do is practice some more scientific notation stuff. I believe I put a homework up where you got to do some scientific notation. And I don't know what the due date is, but since I'm finishing class, I'm not on schedule, I'll extend the due date for that first homework. And then study this table here. Be familiar with this, and I'll pick up with this in the next class. Does anyone have any questions or comments for me before we sign off? Any questions?
Yeah, for the hi, Professor Han. Just for the homework, do you have a link or something where we need to submit the homework or something like that?
What I was thinking about is I was going to have you guys bring it on Tuesdays when you come in for class, because I really don't want to do too much uploading. If I do have you upload it, I'll send you out a link for it. But what I'm going to do is adjust the due date, and I'll probably have you just turn it in when you show up on Tuesday, whatever Tuesday that is. So you probably hand the hard copy in to me.
Great.
Okay. Thank you for that question. Anybody else?
Next week, will we meet online on the same date?
Yeah, we'll meet online on Monday, and we'll meet online on Wednesday. Let me see how things go. I don't think we're going to meet for lab, and if we don't meet for lab, I may do something online. I'll let you know more about that either on Sunday or Monday. But definitely we'll meet Monday for lecture. Any other questions?
Over the engineering notation on Monday?
Yeah, I want to do that on Monday. I wish I could have did it today, but I don't want to rush through that because that's really engineering notation is more important for us in this class than scientific notation. So I want to spend some time with that. So I'll do that on Monday. So any homework that has to do with that, don't worry about that right now. I'll make an adjustment on the due date for the homework. I'll give you more time to do it, and we'll finish up this lecture on Monday, then you'll be able to do all the homework problems. Is there anything else? Any other questions? Okay, well, guys, stay safe. Have a great rest of the day. I'll see you on Monday. Have a good weekend.
Excuse me, Professor Ryan. I'm sorry.
Yeah.
I have a question, but it's I don't know. It's a personal question. Just I sent you. Yeah. I sent you an email before the classes start. That was in the fall. Yes, I'm asking you because I'm working a second shift and they need to leave the lab early. And
Okay.
Yeah, I don't know if you remember me or no.
I kind of remember an email.
My
like
name
that.
is Yusuf Belavki. I don't know if you remember. I sent you an email and you respond me. Just I wanna confirm that you say there's no problem. Just I wanna make sure that just I wanna know if you wanna me I come early or what exactly I need to do. Just
What time you normally have to leave lab? Like what time do you have to leave?
I'm working in Kentucky. I'm living in Kentucky, and I'm working in Toyota. That means if I need to leave Cincinnati, that means I need to drive at least 45 minutes until Hebron. I will bring my clothes with me. I don't have any problem with that. That means the time I leave the class, I go directly to work. but
Okay.
maybe at 3:15, 3:20, that would be great for me. I don't know how is the highway, all the stuff. Maybe they have. That's why I'm trying to give a time.
Well, I tell you what, is it Yusuf? Is that how you say your name?
Yeah, my name is Yusuf. Yeah.
Okay. I'm actually here. Your lab is on Tuesday, and I'm here
Yeah.
all day Tuesday. So what you can do is, I don't know if you're doing anything before this class on Tuesday, but if your morning's free, you can actually come a little earlier and start the lab early.
Would be great for me. Yeah.
Does that work for you?
Yeah, it's worked for me. I don't have any problem to come in early.
Yeah. So, we'll wait to our first lab session, and then you let me know, and then you can come in early that day. I'm here all day on Tuesday, so you can come as early as you want. We'll make it work. We'll work it out.
All right. Thank you so much. Great. That's awesome. Yeah.
Thank
Because
you.
with COVID, everything was changes, and I said I need at least to have classes this semester. I don't like stay without taking any classes. That's why I said let's me do it.
Okay. Well, we'll work it out.
All right. Thank you so much.
Okay, guys. Thank you.
Have a
Anybody
good
else? All right, guys. Thank you so much. I will see you later.